Hi everyone, welcome back. We're going to do some problems from the next problem set for graphs of rational functions. Okay, so let's get started. Here we have our first problem. Let f of x equals x squared minus 11x plus 24 over h of x, where h of x is a polynomial. And we're given some choices for the possible graph of f of x. Well, for these problems, what's most important is that we work with what we know, not with what we don't. And in this first problem, we don't know what h of x is. The only thing we know is the polynomial in the numerator. So what I'm going to do now is I'm just going to factor the polynomial. So f of x is equal to x. We'll put x again. All right. And so 24, that looks like it's going to be 8 and 3, right guys? So negative 8 and negative 3 over h of x. Okay, and that's pretty much the only thing I know about this function. So again, I don't know what the restrictions are because I don't know what h of x is. But I do know, again, my possible zeros. And the possible zeros I have, so the possible zeros are going to be x is equal to 8 and 3. Okay, let me just fix that 8 a little bit. All right, so 8. All right, so those are my possible zeros. And again, depending on what h of x is, if h of x has either of these binomial factors in it, then of course those are not going to be zeros. All right, they're going to be restrictions. So let's take a look at our choices. Again, possible zeros are 8 and 3. They may not be though. It depends, of course, on what h of x is going to be. So let's take a look at our choices. Okay, definitely that one has a possible 0, right? But none at 3. Okay, there's nothing going on for this function at 3. There is a 0 at 8, but nothing going on at 3. Okay. How about this one? It looks like the x-axis acts as an asymptote here, so I don't think we have a value at 8. And at 3, well, again, we don't have a 0 at 3, nor any kind of a restriction. Here, definitely looks like we have a 0 at 8, and at 3, we have a vertical asymptote. So this could also be a possibility, right? If, again, if we have a restriction for h of x at 3. And this one, we don't have 8, and nothing's going on at 3. So it looks like out of all the possibilities, I'm going to say that this is probably our most likely candidate, correct? And so let's check, and that is correct. All right, guys, so definitely something has to be going on at 8 and 3. Whether it's a 0, whether the function crosses the x-axis at 8 or 3, or there is some sort of a vertical asymptote here, right? So either a vertical asymptote, because there's a restriction, or it is a 0. Okay? All right, let's go on to the next one. On the second one we have, again, we are given another function. Now here, if you look at the function, our coefficients are not given for these 4 terms. And also, the exponents are not given for these two terms. So there's a lot of questions on this problem. We don't know which one is the leading coefficient. We don't know which is the dominant terms here. The only thing, again, we have to work only with what we know, and what we know are these two constants. All right? So I do know that if x is 0, so if I were to plug in 0 for x, then this whole function, basically, that would be 0, that's 0, that's 0, that's 0. Everything cancels out except these two terms. So I only have 36 over 9. And that, of course, is equal to 4. So I do know that this function, sorry, just cancel that out. I do know that this function has to go through 0, 4. Okay, it is defined. And of course, we know that a point that goes through 0, comma anything is called the y-intercept, right? So this is the y-intercept for this function. So let's see which of these functions has a y-intercept at 0, 4. Yeah, let's go through our choices. Okay, this one definitely goes through 4, right? Choice A. B does not, right? C doesn't either, and neither does D. D goes through -4, not +4. So I believe A is our choice, right? Okay, guys? All right, let's go to the next one. This function. Okay, now this function is defined for the denominator, but not the numerator. So, again, according to our analysis, let me pick a different color this time. So according to our analysis, again, work with what we know, not what we don't. So f of x is equal to g of x over, and now let's factor the bottom. So if I factor the bottom, it's going to be 2 times, now I'm going to have x squared minus 16, correct? But x squared minus 16, of course, as you all know, is a difference of two perfect squares. So I can continue to factor x squared minus 16. Sorry about that. Just get rid of that. So let me continue factoring. X squared minus 16 is x plus 4 and x minus 4. Okay, there we go. So basically I know that I have restrictions at my restrictions. Okay, restrictions at x equals 4 and -4. Okay, now those restrictions, depending on what g of x is, they could be vertical asymptotes or they could be holes, right? But they have to be something, either vertical asymptotes or holes. So let's take a look at which ones have either vertical asymptote or holes at 4 and -4. All right. Here I have vertical asymptotes at 4 and -4. So A looks like a pretty good choice. In B, I have vertical asymptote at 4, but here at 2, so that doesn't look like it's the one. Here I only have it for -4 and a hole at 2, so that's no good. And this one, again, I have vertical asymptotes at different values for x, right? This is at -2 and 6, so that doesn't work. So it looks like choice A is the winner. Okay, and last but not least, this problem, we have a function, and now we have some unknown constants and coefficients, and only two terms are defined for us. Looks like those two terms are the only ones that we know, and they are the leading coefficients. They are the dominant terms in this function, right? X to the fifth, x to the fifth. So this looks like a problem where we are going to determine what end behavior is, right? So according to our end behavior, excuse me, as the x values get very big or very small, right, as So let me write it down. As x approaches positive or negative infinity, let's see what's going on. What does f of x approach? So you know what, let's do it one at a time here. Okay. So as x approaches positive infinity, okay, what is f of x going to approach? Well, again, the simplified form for this function is going to be f of x is equal to 12x to the fifth over 6x to the fifth. Sorry, the work is not neat. So again, the x to the fifths are going to cancel out, leaving me with 12 over 6, which is 2. So in this case, it looks like as x approaches positive infinity, f of x is going to approach 2. But in the same case, as x approaches negative infinity, f of x, again, is going to approach 2. So it doesn't matter which way we're going, to the left or to the right, we should have a horizontal asymptote at y equals 2. I'm sorry, x equals 2, right? Horizontal asymptote. So let's take a look at which of these choices has a horizontal asymptote at x equals 2. I'm sorry, y equals 2. Why do I keep saying x equals 2? So the f of x value is 2. So which one of these has a horizontal asymptote at y equals 2? Okay. So it looks like this one has 1. A has 1 at negative 1. That's incorrect. B looks like, yeah, B looks like there is a horizontal asymptote at y equals 2. Now again, the function can cross that asymptote when it's close to the origin, but we're talking as the x values get very big or very small, right? So B is definitely a candidate here. C looks like there's a horizontal asymptote at negative 4, so that's not it. And D, it looks like there's a horizontal asymptote at 6. So the only real choice we have here is choice B. Okay, guys? All right. Hope that was helpful.